let's just bypass the small talk today and launch straight into what I promise is a totally mind-bending journey. We're going to start all the way at the very edge of the observable universe, zoom past literally billions of celestial neighborhoods, and then plunge right down into the incredibly dense, mysterious center of our very own cosmic home. If you've ever looked up at the night sky and just felt this overwhelming sense of scale, well, this explainer is going to show you exactly why that feeling is 100% justified. So buckle up.
Okay, take a look at this number, 2 trillion. That's 2 million million. According to a massive 2016 study, this is the staggering estimate for the number of galaxies currently believed to exist just within the observable universe. You know, we used to think space was mostly this vast, empty void, but honestly, the cosmos is absolutely crowded with these massive structures. But what exactly is a galaxy?
Okay, let's dive into this. Instead of some empty void, think of the universe as being packed with these grand cosmic islands. A galaxy is essentially a huge collection of matter. We're talking dark matter, cosmic dust, swirling gases, and billions of stars, all locked together in this chaotic dance. And while the universe itself is constantly expanding and trying to tear clusters apart, the gravity within these individual galaxies fights back. Gravity is the ultimate cosmic sculptor, acting like this invisible glue that keeps everything tightly bound together around a central core.
Now, as you can probably guess, not all of these cosmic islands are created equal. The variations in scale here are honestly almost impossible for our human brains to really wrap around. On the smaller end, you've got dwarf galaxies. These span a mere few thousand light-years across and maybe hold around 10 million stars. But then you have the giants. These absolute behemoths stretch up to 300,000 light-years across and can pack in 100 trillion stars. To put that extreme upper limit into perspective, the largest known galaxy, called IC 1101, is estimated to be a staggering 50 times the size of our own Milky Way.
Section 1. Shapes of the cosmos.
So we've got these 2 trillion galaxies, right? Ranging from tiny dwarfs to absolute giants. But they don't just differ in size. They look radically different too. Gravity paints very different pictures depending on the local conditions. First up, we've got the familiar, elegant structure of the spiral galaxy. These are flat, disc-shaped collections of stars featuring these gorgeous sweeping arms that spiral outward from a really bright central bulge. Honestly, they look almost like brilliant cosmic pinwheels just spinning out there in the dark.
By contrast, though, we have elliptical galaxies. You're not going to find any dramatic, swirling arms here. Instead, these are shaped much more like simple balls or kind of stretched-out ovals. They're typically a lot older, and they lack those vibrant gases and dust clouds that go into creating new stars. Because of that, they appear much dimmer and far less colorful than their spiral cousins. They're really just the quiet, glowing spheres of the universe.
And then we've got the rebels of the bunch, irregular galaxies. Just like the name implies, these galaxies lack any regular shape or form at all. They are often smaller, totally structureless, and visually pretty chaotic. But hey, don't let that messy appearance fool you. That chaos is actually a massive hotbed of creation. These irregular zones are packed with exactly the right materials and conditions to be the nurseries for brand newly formed stars.
Section 2. Zooming into our cosmic home. With trillions of galaxies out there, what exactly does our specific neighborhood look like?
Welcome to the Milky Way. This is us. And here is a truly fascinating fact to kind of ground you in this immense scale. When you step outside on a clear night and look up, every single individual star you can see with your naked eye, they are all part of this one single galaxy. From anywhere on Earth, you might see up to 10,000 stars unassisted. And yeah, that feels like a lot, but it is literally just a microscopic fraction of what's actually hurtling through our specific galactic home.
As you can probably guess from the shape, the Milky Way is a classic spiral galaxy. It's roughly 100,000 light-years across. And remember, a single light-year is about 9 trillion kilometers, so the scale here is just immense. Within this spinning disk, we share our space with anywhere from 100 to 400 billion other stars. Our specific solar system just sits out on one of those sweeping spiral arms. And scattered all throughout this expanse are nebulae, these breathtaking, colorful regions of glowing pink, blue, and green gases where brand new stars are violently being born.
Now, an absolutely crucial point to remember here is that nothing in this galaxy is standing still, not even close. Look at this speed, 500,000 miles per hour. That is the speed at which our sun, carrying the Earth and all the other planets right along with it, is currently traveling as it orbits around the center of the Milky Way.
Think about that. We are racing through space at 500,000 miles per hour right now.
But even at that blistering, unimaginable speed, space is so unfathomably huge that it takes the Sun about 220 million years to complete just one single orbit around the Milky Way. Scientists actually call this epic journey a galactic year. But here's a fun detail. The Sun doesn't just move in a perfectly flat circle. It actually has this vibratory movement. As it races forward, it bobs up and down, taking about 60 million years just to rise and fall. It's kind of like the motion of a human running, bounding up, coming down, but always surging forward through the cosmos.
Section 3. The Dark Heart.
This brings us to the final climax of our cosmic zoom-in. We're shifting our focus about 30,000 light-years away from Earth, directly into the very center of the Milky Way. Because if the Sun and all 400 billion other stars in this galaxy are relentlessly orbiting a central point, what exactly are they orbiting? What invisible, incredibly dense anchor could possibly wield enough gravitational power to hold 100,000 light-years of stars, gas, and dust together in a giant spinning wheel? For a long time, we could really only guess, watching stars near the center whip around this invisible point at just terrifying speeds.
The answer, which planetary scientists now believe is actually true for almost all large galaxies, is a supermassive black hole. Born from the explosive deaths of giant stars, these are points of infinite density known as singularities. The gravity here is so extreme that it literally warps the fabric of space itself, creating an invisible boundary called the event horizon. Once anything crosses that boundary, nothing can escape, not even light.
And this brilliantly illustrates what we're dealing with. Unveiled on May 12, 2022, this is a historic photograph. The very first image of Sagittarius A star, the supermassive black hole living right at the center of our Milky Way. That glowing orange ring you're seeing, that's superheated material racing around the event horizon, right before it plunges into the dark. And that shadow in the center? That singularity packs the mass of 4 million of our suns into one single, terrifyingly powerful point. This is the dark heart that our entire solar system is gracefully dancing around.
So let's zoom all the way back out for a second. The next time you step outside and look up at the night sky, I really want you to remember this explainer. Keep in mind that every single star you see is just a tiny, tiny fraction of our Milky Way. And remember that our Milky Way is just one of 2 trillion galaxies out there, coming in all sorts of shapes and sizes, scattered all across the observable universe. And lastly, remember that holding all of this grand, spiraling beauty together are forces so powerful and so dark that not even light can escape them. It really makes you wonder, doesn't it? What else is waiting to be discovered out there in the dark? Thanks for joining me on this cosmic journey. Keep looking up, and I'll catch you in the next explainer.